Hello and welcome. I'm Dan Ring from Foundry, and together with Will Greenley of DNEG and Jonas Torten of Filmakademie Baden-Württemberg, we're going to present our collaborative work on the SAUCE project around creating a future asset library. Firstly, what is SAUCE? SAUCE is a collaborative EU research and innovation project. Its goal is to create a step change in enabling companies in the creative sector to reuse existing digital assets for future productions, as well as looking towards richer and more complex smart assets. The project is composed of many partners, both industrial and academic alike. Each partner is tasked with producing, piloting, and demonstrating a set of professional tools and techniques to reduce production costs of enhanced digital content. Some partners focus on the development and use of assets that will be important in the near and long-term future, such as light fields and semantic animation in crowds. In this work, Foundry, DNEG, and Filmakademie have focused on asset pipelines as a key area where content reuse can be improved. So why asset pipelines? VFX, animation, and even game studios collect and generate large volumes of data, and that data is expensive to create. Being able to reliably access and reuse previously generated data is incredibly valuable, providing huge efficiency gains and cost savings. Anecdotally, many facilities have said that their success or edge over competitors is due to their asset libraries. With the size of asset libraries growing exponentially, to realize the value of your library, you need modern ways to efficiently store, index, and retrieve your assets, no matter what format they're in. Maintaining an efficient asset library is a problem shared between virtually all companies in VFX, animation, and games. There is no single off-the-shelf tool or service that meets every company's needs, with many companies having written their own system. We believe that there should be a shared, common platform for asset management, with facilities able to add their own secret sauce then when needed. The presented work takes a fresh look at the requirements for a modern asset library system, investigating what a modern asset library looks like, our discovered requirements and use cases, and we address them in the following three sections. The first, storage and access by Foundry; the second, search and retrieval by DNEG; and finally, virtual production and other modern use cases by Filmakademie. The first stage of any asset library system is deciding how and where to store the data. There are many ways of doing this, from simple file system-based network storage to relational object database storage systems. In this section, the design decisions and features of the developed storage system are presented, all of which have come from real customer requirements and have been implemented in Foundry's Flix software. These features could be a minimum checklist for anyone thinking of writing their own asset storage system. The first, and possibly the most interesting lesson learned from customers, is that creative people don't want to work with files. In the same way that something like iTunes doesn't show you the underlying MP3 files, if you're working in a modern pipeline, the asset store should manage the handling of files for you. Once the asset is imported into the storage system, the user should not need to know anything about the underlying file or where it's stored. To make assets useful, there are two additional properties and constraints that an asset should adhere to. That is, an asset must relate to a single, uniquely addressable entity, and an asset must also be versionable. The second important lesson, and a key feature that defines a storage system of the future, is that artists should not need to know what data type or format the asset is stored as, only what they can retrieve the asset as. This ensures both forwards and backwards compatibility with various file formats, and is enabled by a transform engine. This is one of the key features of this work. The transform engine implements a plugin architecture to enable parsing and transformation of assets. For example, if an asset was imported as an FBX file, it could be retrieved as an OBJ for compatibility with legacy software. Similarly, it could be automatically converted to an Alembic file or conformed to the Studio Pipeline's USD format. Here is a demonstration of the transform engine in practice, as implemented in Foundry's Flix storyboarding software. In this demo, we're going to import a USD asset and use the transformation engine to render a thumbnail of the asset so that it can be visualized in Flix's UI. The transformation in this case is enabled by a plugin, which has been uploaded by the Flix client to the server. Now let's look at the asset we're about to import. It's the familiar USD kitchen scene, with the addition of an animated robot and a keyframed camera, where each keyframe corresponds to a story panel that we want to work with. Now when we import the asset into Flix, the USD plugin is invoked. It triggers a render of the scene from the scene's camera at each of the camera's 5 keyframes, using the Embry renderer. Once rendered, the thumbnails are used to display the scene's content, but crucially, the underlying asset is still a USD file. I've just shown that knowing the type of an asset can be valuable. However, the variety of file types in VFX and animation studios is staggering. A key requirement of an asset library is that imported assets cannot be limited to known file types. Each asset should be stored regardless of file type, with the provision that if a file type is known to the system or becomes known to the system later on, it can be operated on in some way. When an asset is requested from storage, it needs to be easily accessible. This has been implemented through a simple and well-documented REST API. Modern pipelines and infrastructure can be heavily customized. Therefore, having a well-used language and software-agnostic way to retrieve assets is vital. The storage system must provide redundancy and load balancing to guarantee performance. We achieved this through server-side replication policies, two of which we found to be most effective. The first, a copy-all policy, ensures that data is copied to all sites, ensuring high-performing multi-site operation and high data redundancy. A don't copy policy ensures data is not automatically moved between servers unless requested by a client. This helps reduce unnecessary replication of assets and is very useful when multiple sites, or even multiple servers within the same site, are being used for different shows, for example. The cloud is becoming more and more attractive for collaborative data access, particularly where data needs availability, redundancy, and performance guarantees. While concerns around cloud security are easing, there are still cost, knowledge, ownership, and integration barriers that mean customers often prefer to keep data local. The presented system has been developed to operate both locally on a facility's existing infrastructure, as well as in the cloud, or even a hybrid of the two. And lastly, the storage system needs to work in modern VFX and animation studio pipelines. This means that all of the above features must be delivered through the storage system alone. For example, while cloud-based load balancing and replication services could be enabled by running the storage system in the cloud, some functionality of these features must also exist without third-party services. The idea is that the system should be able to work independently and work easily for both large facilities as well as small studios with no IT departments. This has been achieved largely through containerization and an intimate understanding of customer infrastructure to minimize deployment issues. Now that we've presented how assets are stored, the next challenge is how to efficiently search and retrieve them.
Hi, my name is William Greenley and I work for Double Negative in the Production Technology Department. I'm going to discuss some of the common challenges facing visual effects houses when trying to search for and reuse assets across a variety of asset management systems, and then explain how the source framework addresses these. In the case of Double Negative, the company has millions of assets spanning decades of production. The cost of getting a human to manually curate every one of these assets could be phenomenal. Furthermore, curation is invariably inconsistent. Different teams have different ways of curation, and from a search perspective, these are not uniform or interoperable. The Source project seeks to address these issues by providing a framework for classification, search, and transformation of reusable assets. To begin with, one of the fundamental ways we address many of these data-related problems is by canonicalizing our data and adopting a mature and established set of data standards, namely the linked data standards. These standards form the basis of our asset data model and provide a means to extend this model with vocabularies and ontologies in a decentralized and autonomous way without the need for consensus or agreement across teams or departments, whilst at the same time maintaining interoperability of models, allowing partners and domain experts to contribute specific vocabularies, ontologies, and models for different types of assets, e.g. rigs, meshes, animations, etc. These standards also allow us to leverage and take advantage of a number of existing vocabularies and dictionaries, i.e. WordNet, Wikidata, and schema.org. By using these, we don't have to invent tags and terms for describing things, taking advantage of established knowledge bases, and only extending them with industry or organization-specific concepts and vocabularies. These vocabularies form the foundation for a classification and transformation framework. This framework allows asset and domain experts to leverage machine learning and introspection to train models for classification and enrichment, and to chain and compose complex classification networks. Instead of training and classifying using traditional machine learning techniques, namely string labels, we train and classify against concepts found in our vocabularies and dictionaries, thus augmenting and complementing our classifiers with established knowledge bases and enabling greater levels of interoperability, thereby exponentially increasing their effectiveness and value. Furthermore, by leveraging axioms and concepts in our dictionaries and vocabularies, we can materialize synonymity, hyponymity, similarity, lemmas, and inflections. The resulting enriched assets are exposed via rich graph traversal search API. The transformation framework also allows contributors to express transformation options and transformation capabilities, thus widening the search results and including results that could be achieved through one or more transforms. Finally, an extensible and intuitive search user interface allows artists to efficiently search and retrieve assets leveraging the search API. The following video demonstrates some of the key features of the user interface. The search UI supports a range of modalities and displays. Artists can browse assets intuitively and efficiently, comparing different results using a variety of sorting and ordering controls. The asset data model has an extensible type system, which enables artists to search using full text and asset type. In this example, the artist is trying to find relevant textures using depictions and the filter. Individual assets are displayed using renderers and display components most suited for the type of asset. In the example, a texture is displayed and rendered with a 3-point lighting. This includes a toggle between 3D preview and sources. This also includes a display which shows similar assets to the asset retrieved. The details view also includes attributes extracted during enrichment and classification, specific to the type of asset. Some displays also include interactive controls, allowing basic manipulation and editing for preview purposes. In addition, the user interface allows artists to find assets by geographic location and time era. Interactive controls enable artists to filter intuitively and efficiently so they can find assets associated with geography and landmarks or during specific points within history. The expressive type system enables rich class traversal of assets, allowing artists to find groups of assets by semantic types, and then narrowing or broadening those groups to include related or similar assets. The modular design allows search components to be served and integrated independently into existing legacy applications, thus allowing artists to find assets in a variety of contexts.
My name is Jonas Trotno. I work for the research and development team at Filmakademie Baden-Württemberg in Germany. I'm going to talk a bit about the transformation possibilities and concrete use cases of the asset library framework in virtual productions. An often underestimated overhead for virtual productions is the asset preparation. All assets, even the 3D assets, need to be available on set prior to the shoot. As an example, you also need different versions of the same asset. For example, you need a high detail version to judge visual quality and a reduced detail version for real-time purposes. The search and transformation framework provides the possibility to integrate such a transformation as a plugin, thereby simplifying the preparation of a virtual production and making it more attractive for smaller studios or even individuals. In addition, the framework can transform asset formats. For example, many DCC applications support USD nowadays, and such a file transformation can be executed directly in the search and transformation framework. In a virtual production context, descriptive metadata that can be provided by an asset library like the one presented here can greatly simplify the setup and authoring of an initial scene. For example, assets that are explicitly suited for virtual productions can be found conveniently in a semantic search. This could be, for example, real-time capable rigs or assets with fewer polygons and so on. This metadata can not only be used as a search term, but can also serve as a guide for the transformation part of the framework. If an asset does not fulfill all requirements of the search, the framework can look up if a transformation plugin exists that is capable of automatically transforming the asset to fulfill all search criteria. This kind of makes the asset smart in a way, and since all of the automatic adaptions can then match the requirements of the search. Based on the labels, assets or a scene can be transformed for use in virtual production environments, for example in VPET. VPET is the virtual production editing tools developed by Filmakademie Baden-Württemberg. It's an open source toolset that enables staff on a movie set to visualize, explore, and modify virtual elements in augmented reality. Collaborative and synchronized work with multiple clients is possible with the framework, and through its open architecture it can be seamlessly integrated into existing production pipelines. Through the labels provided by the asset library, the search and transformation framework is able to simplify the setup process for toolsets like VPET. For example, movable objects like cars, benches, and so on can be separated from static ones like houses. And these movable objects are then marked as editable in the VPET system, enabling a user to select and modify them in real-time on set on the VPET tablet clients. In addition, the labels can be used to provide scene understanding, for example, for the animation solving engine in order to generate scene-aware animations. So, for example, in VPET, you're able to direct an animation on the tablet clients, and those animations will be solved on a host system running an animation engine. Such an animation engine could then consume labels describing either individual objects or entire scenery. And within the source project, we, for example, tested the automatic identification of so-called mood regions, which could be, for example, a scary alley or a cozy park. And this identification is done through machine learning. If a character enters such a region, the animation engine could then automatically adjust the animation accordingly. This can be used for on-set virtual productions, but also, for example, for previs. A concrete application for virtual production based on an asset library is the VFX car shoot realized by Filmakademie, where a real car is placed in front of an LED wall. Such technology is also known from productions like Mandalorian. In our case, the stage is surrounded with LED panels, all walls, and even the ceiling is covered with 91 million LEDs. These serve as a backdrop, replacing, for example, technology like green screens and even the lighting. Through the search and transformation framework, the imagery being displayed on those LED walls can quickly be exchanged on set. The director wishes can be quickly addressed and sourced from the existing databases, and if necessary even be transformed to match the formats that can be displayed on the LED wall. 3D elements also rendered on the LED wall can be placed in the middle ground between car and background, and even animations can be run in real time there. Camera effects and compositing will be handled on set directly in camera. The aim is to use VPET to enable users to interact and modify the 3D elements provided by the search and transformation framework in real time.
In this talk, we have presented a modern end-to-end asset library system. Summarizing a comparison to other commercial or in-house asset library solutions, the key differences in approach between those systems and the presented SOS system are that SOS focuses exclusively on VFX and animation. SOS also aims to create a common shared platform with open, well-documented APIs. And SOS enables extensive customization through user plugins, both for storage and for indexing and retrieval. To wrap up, the key contributions of this work are as follows. The first is a detailed set of modern asset storage system requirements targeted for VFX and animation, and derived from real customer feedback. Although the presented system is implemented in Foundry's Flix story development tool, the requirements serve as a checklist for any facility wanting to develop their own asset store. Next is the presentation of DNEG's search and retrieval system, answering industry-specific problem statements. In particular, it demonstrates how to reduce the cost of human interaction, and the value in supporting system interrogation by a plethora of data types. It also illustrates how to make the most of rich data and how to enrich poor data through an extensible framework for classification and enrichment. Lastly, Filmakademie's virtual production experiments demonstrate the value of the transformation frameworks. Virtual production is becoming increasingly popular, and the richness and variety of the data that is both generated and consumed means that there needs to be a way to simplify the transformation of assets for easy reuse in different contexts. This is vital in making virtual production more accessible for smaller studios and for individuals. If you're interested in finding out more about smart assets and their reuse, more information on the SAWS project and its partners can be found at the following links. And finally, thank you for your attention.